Namaskar, my dear friends. Let us continue the discussion of step-by-step process how to design microcontroller circuit. So we have seen MSPM0G series and the device that is selected is 64-pin LQFP package. So MSPM0G3507 is one of the latest microcontroller that has been released by Texas Instruments, and we have already seen several questions that we have discussed in last, like how to do programming, reset or decoupling capacitors, how to design the power supply management like different voltage rails and all those things. Then we have also seen how to connect the ADC lines, alarm buzzer, IR sensor, temperature sensors, and then we have also seen ambient light sensors like analog ambient light sensor, I2C interface ambient light sensors, then EEPROM interface also we had seen last time, right? Now there are a need of connecting LEDs. So how we can connect LEDs, that we'll see now. Okay, so there are various aspects of connecting an LED to microcontroller. So let us say this is a microcontroller that is there. Okay, and what we can do is we can either connect like a power supply with resistor and then LED connect it to there. So this is how one method is this one. Another method is connect resistor and then connect it to LED. This is how, and then connect it to ground. So this is another method, and controller will be acting as a power supply to this LED. Another method is drive this particular microcontroller output to to some MOSFET, and this MOSFET can be connected to an LED with your resistor. So this is how another method with one 5 volt or something like that you can connect it. So this is the microcontroller that is going to switch on switch off this particular uh, your MOSFET, and this is how it can be very easy. So there are various aspects of connecting an LEDs. Okay, so let us see this thing in your schematic. So what we can do is we can see this. So see here, what is connected is these three LEDs that has been connected, and microcontroller is being used as a sync pin. Okay, another one is these are the three LEDs that has been used, that is RGB LED. In the same package, all these red, green and blue LEDs are there, and they also are powered up by 3.3, and the MOSFETs that has been used, they are being switch on or switch off based on the requirement that is needed. Okay, and in that case one of them will be glowing at a time. Okay, good. Coming back to the other question. So let us say how to connect push buttons and deep switches. Okay, so generally sometimes what is the need is we want to connect some push button, like once we push it, so what will happen, the microcontroller that is going to your user PB0. So this user PB0 right now it is seeing a high. Okay, so it is seeing a high. Now as soon as this is pressed, as soon as this particular switch is pressed, this will this pin will go ground, and in that case it will see a low. So this is how whenever the push button is pressed, microcontroller will see low, and this is how you will be able to understand that okay, button has been pressed, and based on that you can take some decisions. Similar to that, we have deep switches. So let us say this side it is open and this side it is closed. Okay, right now it is just opposite side. Okay, so once it is this side, it will be close, and once this side it is open. So once it is this side left, right side, what will happen is these deep switches will be seen to the microcontroller that they are grounded. It means they are 0. Now once you press this side, then what will happen, they will be becoming high. So this is how you can do that job. Okay, and this is how you can connect your deep switches. Similar to that, PWM output connector and external interface. So what we can do is we can take up, let us say I have taken a connector of 8 pin connection, and then this PWM 1 2 3 4 5 6. So if you want, you can have all these PWMs in complementary method as well, so that you can drive it some IPMs or maybe full bridge rectifier or full bridge circuit, so that you can drive some motor as well. Okay, so this is how this particular PWM connector can be utilized. Another external interface has been used to take out your inbuilt op amps, op amp minus, op amp plus, and op amp output. So this can be connected to some external circuit, and that can be amplified through this particular op amp minus, op amp plus, and all these things. Okay, one DAC output is there from the microcontroller that has been also taken to this connector, so that you can drive some audio signal, or maybe some circuit that requires a DAC. Got it? Now let us get back to the separate DAC circuit. So I have used like 116-bit resolution separate DAC is there. So that I'm going to introduce now. So what we can do is let's go into the circuit. Okay. So this is the DAC that has been used, which is AD5543. So 16-bit DAC is used, and this is going to be having a power supply of 5 volt and voltage reference of 3 volt I have given. If you want, you can keep it 2.5 volt as well. Okay, so in that case you have to use some other voltage reference IC. Okay, so voltage reference I have generated 3 volt, that's the reason I am giving 3 volt. Now this is going to give you an output of current rating. So it is going to give you current. So I have used current to voltage converter. So this is going to convert it to voltage, and this will be converting to minus volt, okay, negative voltage. And in that case, what I am doing is I am amplifying it and sending it to the output, and this is going to go to your minus plus minus 3 volt range. Okay, so plus minus 3 volt range, you will be able to get your output. One of the best part is of this particular circuit is this requires negative supply voltage. Okay, in that case what you can do is we have 5 volt power supply available, as well as we have VDD, that is 3.3 volt power supply, right? And just to supply this particular op amp, we don't want to connect one separate negative voltage regulator or something like that. In that case, what you can do is you can use a separate charge pump. So this is called negative voltage charge pump. So you can use ADM 8660. So if you supply 5 volt, the output will come as minus 5 volt. So P5V, that is positive 5 volt, then it is going to give you N5V, that is negative 5 volt, okay, with 100 milliamperes of output rating. So that is more than enough. So this is a very quick solution for your schematic requirement. Okay. Good. So now coming back to the other part. So we already saw voltage reference and negative voltage power supply, and then we have CAN transceiver and lean transceiver. So CAN transceiver will be having signals like CAN TX, CAN RX. Then we have voltage level shifter requirement like CAN, the microcontroller CAN TX RX signal will be giving you 3.3 volt, and the CAN transceiver will require 5 volts. So in that case, we need to have a voltage shifter, and then EST protection of your CAN low and CAN high. Similar to that, we have a lean transceiver also. Okay, so what we can do is quickly, if we want to see okay, so as you can see, we have CAN TX signal and CAN RX signal coming from your controller side, that is your microcontroller. So you have to identify which pin is actually capable of giving you CAN TX and CAN RX. Okay, so if you want, I can show it to you, like where is my CAN TX and CAN RX in my page number 1. Okay, so let us say this is the pin that has been used, pin number 5 and pin number 6. So you can see CAN TX and CAN RX. And if you want to identify those pin, what is the first step that you have to do? You have to go to your pin, like signal description or signal attributes, and see that. So go to the data sheet of that. This is the data sheet, and go to the CAN signal. So see, CAN signal is there, CAN TX, CAN RX. You can see 64 pin. We have pin number 5 and pin number 6, and pin number 30 and pin number 31. So either you can connect it to 30, 31 or 5 or 6. Any one of them you can use, because it is having only one CAN signal. Both of them cannot be connected. Any one of them only will be used. Okay. If you are connecting both of them, then only one of them will be working as a CAN TX, CAN RX at a time. Got it? So hope you have now a good understanding of how to assign the pin. Now let us see the circuit. So what we have done is this CAN TX RX signal is coming to 3.3 volt label. So now this is going to get converted to 5 volt level, that is your VCC supply, and this 5 volt level is going to go to your CAN 0 TXD, CAN 0 RXD. This CAN 0 TXD and RXD are going to get connected to your TCAN 844. This is a CAN transceiver, latest CAN transceiver that has been designed by Texas Instrument itself. Very low cost and very a nice IC. And this is going to give your CAN high, CAN low differential outputs. This is also terminated with 120 ohm with a split technology. So this is 60 and 60 you can add, but 60 ohm we generally do not get. That's the reason 60.4 ohm is used. This output has been actually ESD protected as well. So bidirectional ESD diode has been used. Okay. And you have a filter output as well. So the output lines has been also filtered. And this particular connector will give you the access of the CAN high and CAN low signal, as well as it is having power supply as well. So if you want, you can power up the daughter card or maybe your external circuitry or something like that. Okay. So this was all about CAN transceiver. Coming back to lean transceiver. So lean transceiver will require RXD and TXD lines. So in that case we have UART signal. So one of the UART pair has been used to supply, receive and transmit signal. And similar to that, the output is going to go to your lean bus. So this lean bus, so this particular lean transceiver is used as TLIN 2029A. Okay, that is also from Texas Instruments. So I feel Texas Instrument ICs are a bit lower cost and bit standard wise. So that's the reason I am selecting from them. And as you can see, we have a lean bus output. It is ESD protected as well. So lean bus output, you can take it to a connector. So lean bus connector is this one. So if you want, you can take the output there. This particular connector is having the DAC output as well. So 16-bit resolution DAC output is taken here itself, and the power supply is also given so that you can power up your some other parts or some other parts of your circuit. Okay, through this connector. Coming back to the power supply of this particular lean transceiver. So power supply V input itself will be able to power supply that, or and it is actually protected, like reverse protected with a diode, and then ESD protection with this particular unipolar diode. And these two are capacitors and filter capacitors, so you can see that. So all right guys, hope you have now a very good understanding of how to take a question and then how to solve that in a circuit. And this is how slowly, if you proceed, you have a complete circuit. Like you can see, at a time if you try to see this particular circuit, it is very difficult to understand like what is happening throughout this part. Okay, but if you take one question and implement it, connect to that particular pin number, so it becomes very easy. Okay. And this is how slowly you will be able to develop a complete circuit. And this 7-page complete system design, it will be there in your hand within few days. Let's say if you want to spend in the beginning, it may take around a week time, or even a month it will take, because you have to select a component, you have to approve them, verify them, you have to be sure that the component is compatible to your design and requirements. Okay, so all these things you have to take care of, then only you will be in a position to start designing the circuit. Okay, so good. Hope you have a complete understanding of this step-by-step process of microcontroller system design. And still, if you do have any questions or any requirement that needs to be solved, you can always put down your questions in the comment box, or reach out to our channel contacts, like email ID and contact numbers are given. So you can message us, or you can email us your questions or your requirement, and you can always try to connect to our live training, or video recorded trainings that is required to you. Okay, thank you.